Okay, lovely people. This is that rooftop and the ductwork I talk about and why it's so important to help you evaluate what happened, how the roof collapsed. It presents as rolling towards us. Let's take a look. I'm going to show you this section here, and it goes into this structure here. I'm just going to take away. We're going to just take a section of it. Goes into the building. As you can see, the back side of it. It's flanged. Goes to the block wall there, and of course we have this section going here. This section, that's the degree of it. And we would look at this degree here like that, if you want to see that one. When this section went down, it did rotate the ductwork in that direction clockwise. So that's clockwise. Rotating duct, just shifting it a little bit like that. But importantly is the ductwork is not damaged outside that wall there. How do you do that? Well, let's take a look at this again. Oh, okay, so the wall, so looking at this wall system, at the collapse rather, I want you to think of it like this. The punching shear went down like that. All right, think of this flooring here, decking as you can call it, roof decking, that it butterflied in that direction, and this section here rotated down. Not rotating, I'm going to turn it sideways, not rotating this way initially. So let's do that section. I'll just take a square of it. That's where you're going to be looking at it again. But not rotating down like that initially. Notating, so here is, this will be north, south, east, and west for the orientation I'm talking to you. So not rotating northwest, but first rotating north-south, and then west drop first, and then east. So west would be over here, this section here, and then east would just be behind it. This is another section that eventually fails, ultimately fails, pulling on the back of the structure. But this section here is ductwork related. All right, let's show you why I can say that. All right, so first off, we have a ledge here. And I talked about the ledge before as it relates to the surface of the walls here. This is the reinforcement that goes apart. That's in video number 4 if you go look at it to follow this. This fracture shows that the hinge was way out there. So first off, I get to choose. I get to say the hinge, or if you guys believed it went the other direction, you would say there's a fracture line. If you believe it started from this way and worked its way back, and not rotating the way I'm stating, I'll address that with how the box would fail. The box would rotate, and when it rotated, it would torque this. It would rotate the ductwork because it's failing from that direction. It's rotating in that direction. I'll show you in a moment. But if we have rotation away, from this box rotating away, rotating away, then now we have, okay, let's see. Sorry guys, I'm writing on the screen and it's a little jumpy right now because it's also on a tripod. So this is the way I have it rotating away. All right, let's go with, you don't see the jumpiness, I do. Not until we get to camera we might see jumpiness. So I have the fracture here, right across there. That's that rotation away. And let me show you more. So here's the flange that goes in there, inside. There's the segments, the duct segments, if you will. There's a slight bit of rotation out of there, but you see that this angle is still the same, that 90 I showed you a moment ago. So the ductwork stayed stable. pretty much there. And the rotation happened when this ductwork, I believe, when that big fan unit went down, it pulled and rotated the duct, rotating it like that. And cinder blocks right there that fell from top of here, denting the ductwork here. And that rotation, we lose a leg. I think it is on one brace, but it still stays in the air. And noteworthy, here's the end of the wall, and this appears to be pretty much the walkway where they would come back, right? Where they would come into the structure. That's the walkway, the floor. And then it would turn, here's here. And we have a turn and a turn back to the units, back to the condo units. That's pretty much the floor, I believe, right here of that. And this ductwork would have been right about here into the wall. From here, you can see that flange I'm talking about. That goes into the 8-inch block wall. I believe it's 8-inch. And then there's the flange there. And we can see the ductwork looks pretty good here. And that's that rotation part of the connection. And that 90, remember I described that 90 a moment ago? That's pretty present. But there it is with the ductwork as it entered into the structure. And again, I think this is the walkway here, back to the wall, back to this wall. From this image, we see that they've removed the ductwork, probably making it more stable for what they think would be more stable for the workers below. But now we get a better image of that flange system I talk about, and it might even be a little bit of an adjustable boot, a flexible boot. Very interesting on that. And let's see if we can go with this. I doubt it. I doubt that flexible boot thing. I'm looking at it, trying to get a better view of it. This is the part, I believe, that's inside the structure that you observe is not bent. That this is, even after they impacted and moved it as such, this is pretty much flat. So now I want you to look here. This is the ductwork. I took liberty and put some internal there, but we'll bring it out more in line, more flush. This is a section I used, just a section, and to help you see it better, I put it. That's the outside wall. And it's just modular. I can pull this apart, as you'll see in just a moment. So top view, let's pull it out even with the flange. All right, now I'm going to lift it in the air. I'm going to pull it towards us, rotating towards us. So I'm going to make the stationary, anchor to the deck. So my hand's going to stay stationary, left hand, right hand's going to rotate. Look at that. When I do that, all I'm doing is torquing my left hand. It's not going anywhere. It would have to rip. So if it rotated towards us, this section of the roofing, if it rotated towards us, it would break this ductwork. But remember, we saw the ledge sticking out. So I would be torquing it back. That same rotation would have to take place back here. But I've got pulling here in the corner. If you look at video number 4, it's pulling it out and in towards this direction. So that would be northeast, pulling it more northeast. Now, if I do a rotation out here by my right hand further out, you can fracture it here if you like. Now, that would help you get the separation. Look how easy it just pulls away. So I'm just going to rotate the right hand down. Just pulls away, leaving the flange unharmed. If I start rotating this direction, I'm going to create that problem I have. Besides the fracture in the deck, doesn't indicate the fracture in the deck comes out significant. So it gives me a hinge point back here. But there's still wall missing, so it pulled away. Remember the rebar that I show you on that in video number 4, how it's there. Now let's look at the side profile, rotating towards me. You see the issue. Now if I just drop away, it just drops away. Simple as that. It just drops away. So now this is why I have the rotation to failure, not coming towards us. but dropping away, which puts it a butterfly, if you will, back to the butterfly. So that puts us back to the butterfly. Now remember, we have some decking here, some decking that comes out and back, returns maybe somewhere about there, and I think it comes like that at the doorway. So the doorway is here, so like that. Let's clean that up and do that again. Something like this. All right, so then we have this fracture line here. Fracture line there. And we can't have it rotating towards us because but this wall system has been removed. It didn't save the wall system. It went down. It actually, when it rotated, it pulled away. And some of this wall system right about here went down in here, the debris field, as I show in, I think, number 3. But to the right, we don't have the ductwork. It was important that I mentioned that block that I said, remember that piece of block right here? I keep talking about that piece of block that's sitting on top of the ductwork, maybe right here, a piece of block. You see no block on top of this. You don't see it dented, so it didn't have that rotation at all. I mean, it didn't have that rotation at all. It didn't torque, it didn't bend that. It didn't go this way, all right? So folding down, as you see in the video, it presents as a video, it looks like it's folding down towards us. In reality, so this would be, let's change it for orientation now. This is north, this will be south. This will be east. I'm sorry, so I'm going to make this south because that's where south belongs. So let's screw this all up. North, south, my brain, the way it works. West, east. All right, so going from north to south, we would torque that. That's not happening apparently. And then going from west to east fracture and getting punching here, shear here, we also still need to pull in this column over here, this bottom column right here that pulls in. It's got a directional torque. It looks like that. It's pulled in. We have the fracture in the wall, the same wall plane down underneath of here, down here on this wall plane here. We have a fracture here. We have the fracture here, and it's the base, so that's a rotation point, and it's pulled outwards back towards this way. So it'll be west to northeast across this plane here. And I would argue lining up with this punching shear zone here around this column. And also we have the door, the reinforcement that comes across from the wall system back there. And we have 2 pieces of rebar hanging there, as you see across that door. I showed that in video number 4. Got to look at video number 4 to understand this a little better, and 3, and go backwards to understand even more. That rotation in knocks out part of this block wall because this is a parapet wall right around the building, as you can see right here. I guess I didn't do that well. So parapet wall right there. That's this wall too, also rather. And that's our rotation. So looking at this, I believe that, again, punching shear took place around from the deck. We hear a lot of, part of it, a lot of creaking and a lot of things going on where a lot of noises are heard, I believe. And you see this rebar left up top. That took a hell of a stress to strip this bracing off. One of them's going to be bracing. It's so close to being back to the cantilever support of this structure. Oh, that's a hell of a cantilever. And they didn't do it thinking like the engineer here, the contractor there. They did not. I can't imagine them, doing it's a little bit of a transfer beam here. This one right here, going all the way over, just to support this header system here, this little parapet wall, and part of this flooring here. I think it's done this way, though. It comes all the way over, and it supports a beam here. That transfers another beam on this side. So on the opposing side also it does double duty, two intercepts, two beams. So here's a girder here. Let's say multiple girders supported by this transfer beam down to the column here. Column, not the pool, not the floor. I don't think it's on the floor. I think it's on the transferring column up. And then here's your column up from, I think it's G. I think that's the G row. So this one might be more like a brace. I think this guy, you're looking at how he cut corners in the parking garage. I don't see him all of a sudden coming up here going, I don't like this, you know, on my overhang. I don't like it doing that. But if you're going to look at this wall system here with the door, remember it's a doorway there too, it is loading onto the roof. And that's approximately where we still have in place this, it's like a wedge. It's start wedging away. Let's do a red. It wedges away like this. And this is that, we got to say what's inside that wedge. Inside that wedge is this wall system. You know, was that little bit or a significant amount of loading on this? Did it add rigidity to it? That's questionable. Did this wall system here loading on top of the floor only, not on top of any transfer beam or anything else? It's block wall, but they apparently transferred this new roof load here across beams, like I said. So this one would be a little bit of a cantilever, as you see. This section here would be more cantilever, as the beam would be like this across this transfer beam. Transfer beam being this one over to here. So there's a little thing going on there. Did he configure that? I don't know. And this one to the right, let's look at this now. So yeah, it's nice and supported there. This is G. This would have to come back to here. And I think there is a wall system in there that would allow for a column support transferring down to the wall system, to this outer wall, which is the shear wall right here. So this would transfer over there. I think there is some support over there. Thereabouts. I still have to look at that a little differently. Yeah, okay. So now you're seeing what I'm seeing with the rotation. That I believe it rotated down. Punching shear took place. This pulled in. And then what you see is, and we get buy some time. Maybe they hear some, you know, it's part of fractures, and they buy some time to leave. Only a few floors down, she identifies an opening in a wall. If we look at the floor below her, is it 8th floor? She's on 8? 7th floor. If you look at the video, it doesn't, as it's filming, you can hear popping also in that video. So sounds of a building collapsing, as Don Lehman, professor, stated, you know, theorizing that, well, you don't have to theorize, it's actually, that's literally the sound in the NIST camera, the NIST video, NIST, not NIST video, the chime video, whatever, the door video camera, I forget what it's called. I'm thinking Nest camera, and not NIST, Nest systems, you know, for alarms and all that. So I forget the damn name of the camera company. The doorbell camera, it was on the wall there. So I think that's what we're looking at initially. And then it buys some time. And then when the camera picks up, when the building finally collapsed, the camera across the street picks up and goes back, tracks 8 seconds, and this is all it observes. It's everything it observes. So perhaps there was, you know, one primary failure up here. A major primary failure, how about that? Because everything else is primary too, also rather. So, and then some time was bought by, you know, some creaking, whatever they thought they heard. They woke up. And then moments later, the structure was overloaded down here. The rest of the structure, trying to support this in multiple fashions, multiple redundancy fashions, including, you know, trying to recapture it back up and down, transfer loads, multiple directions. That a few minutes later after the phone call, the collapse happened, because I don't know if everyone would have heard that parking garage collapse. The first people went right to the parking garage, but not many people did that, did they? And so I like this as a primary. It could even be delayed. You don't have to be all in one shot. This could be a delay. Fractures, breaking noises, of, you know, the rebar failing, things like that. Rebar concrete and rebar marriage failing. And then you get your total, you get delay, 7 minutes. And then, vroom, the rest of it, it can no longer hold, and we see it all engulfed at that point. That's my current solid theory. Again, that stops what typically everyone thinks they're looking at. I think everyone thinks that, besides me, or at this point, is they're looking at the building taken down like that. That everyone thinks. Besides me, if I don't say everyone, I can't include myself, right? So I think everyone has the idea that they're looking at this, the deck going down like that. Whereas these indicators, like I said, this one pulled in, indicates it needed a tug to pull it in. All right, this is a smoking gun one, as far as I'm concerned. Smoking guns go, that's a tug, and it's inward. It is not forward going the other direction. All right, it's from the base, pulled out, fractured here. Go to video 3 or 2, whatever one I show it in. So right, this is after they put this on the ground, but after they put it on the deck. But here are some blocks. Some of it comes from the parapet wall to the left, and some of it is from that wall system after it rotated from here. It buckled and fell back upon the floor deck, the roof deck. But giving this a full pass, because it shows no cinder blocks on top of it. It shows flat. Any other position, it shows better than this. This is on the deck now. This one right here, this is the one that I'm showing on the deck. So there's your flange, there's your block as it rotated. The wall buckled and fell back onto the deck, missing this. If it went the other way first, rotating left first, we wouldn't get this. The stockpiling would be different. And we also, this is a piece of, can't see it in this one. I need to get you a better image. And here's this angle of it showing pulled out. Pulled out. And then there's your wall that's no longer in plane. And the tug is from, go to video 2 or 3 or 1, whichever one I have it in this series. There's 4 of them. This will show that this is not this direction heavy, but it's this direction heavy, meaning it's on this side to the right, to the east of our video here, if we're looking at it, to the east orientation. Remember, this is all a shear wall. So the elevator on this section, the walls, the floors stop and they butt up. The floors stop and then the walls get poured on top of them. All right, these walls get poured on top, as you may see. With the floors, looks like a sandwich, right? Sandwich going all the way up. Sandwich, floor, wall, floor, then wall. Whoa, that was shadow. That was shadow, guys. All right, so to the right, we see the extended floors out. Again, you see what's up there, and this is very telling, like I said. But this guy here is kicked out, and if this just went down like that, why is it kicked out here? That would have gone. You'd have to hang on, things like that, and we would see it dragged across here, more than likely, and we would also see other things like this panel here that hung on. That panel hung on and flapped over. That's progressively down the collapse system, so it's a little different story down there. Here's where your extension went out for your floor. If we can look at it from the top, from this way like this. This is the wall there. The one that, and there's your ductwork here. That would have been, no, that's a column, but the ductwork is here that I described, and that I'll show you one more time. But again, look here. Go back to 2 or number 3 I have in this video, and you'll see me really go crazy over this right here, where it's pulled in, identifying its location, what would have tugged on it. So ending with the model again, you can see that I can easily, let me square up with it, fall away. Or if I try to rotate towards me or away, it's just going to hang up. It's going to twist this ductwork. All right, it's going to twist it. But I can fall away, no problem at all. All right. Once I have that floor go away, all I did was release it. I got bound on the table there, sorry. So let's do that. I'm going to release the right hand, which is elevated. And you see the ductwork's still good. All I did was release the right hand, and the rotation happened. Hopefully you can appreciate this video content. Do what you can for me. Share the video, you know. Say hello, don't say hello, whatever you can. Take care. Love you guys. Bye.